Okay, good evening everyone. So today we will see the final part, how to aggregate and merge data in Pandas using different data frames. So we will be using Lego data sets. So mainly we will be using sets data uh, and then themes data, and which we already used, and I think more data is like, yeah, colors data. So today we will be seeing the remaining part. So just let's see how to visualize the number of sets published over time. So for that, as we already know, we need to import matplotlib. So the first thing we have to do is import matplotlib in the import statements code. So just we run it. So now it is success. Now let's create new series. So yesterday we have already created. Now let's create a new series, and we will be uh, plotting that how many years data is there for sets. So yeah, we have read sets. So yeah, yesterday we have seen till this thing where we have seen what is the ascending number of parts, where which theme is having a more number of parts. So now we will be starting from here. So now we will be series. So so just it's by grouping the data by year, and we will be using the count method. So we will be chaining this method. So calling multiple methods. For example, we are calling group by on this data frame, and again we are calling a count method on this. This is called chaining. So and then we are just once we load it, we are just seeing the head. Here the head will be remain same, but from our PPT and from our screenshots, it will be differing in the tail. So because it's having only data up to 2021, 2020 precisely, but our data is having up to 2024 this year also. Like, but it's still because it is not our, that's why we are having less number of that. So let's show the number of the same thing we will be using. Here they have given 2020, but but if you plot the same thing, because we already plotted, so the entries, it's all this is for old data, but we will be having all the latest data, but we won't be considering the latest 2024 data because it's still not over. So whenever we plot a graph, it will be not ideal. So here, how to exclude that? It's like a data slicing. We already seen in our starting classes, where we have sliced the list using this indexing. So it represents from starting to last minus 2. We will be excluding last two elements, and from starting to excluding last two elements, we will be taking all the elements. So similarly in the data also it will work the same way. So here we are taking the index. So index we are actually taking all the from starting to minus 2. But for example, if you see, let me plot without slicing it. So we have already plotted. So if you see, it's a declining trend, but actually what's happening, it is not correct because 2024 is not at over. So we will be plotting incorrect data. So because we have already data, I am excluding last one uh, record. So for example, if you see, it's I will be excluding this 2024 record. So what are we excluded, and then we have plotted. So now the graph looks perfectly fine. So just it got decreased. So depending on the trends, if you see it's around 2000, it got very hiked, and after some 2000 might be 2005, it got declined and then got increased. So this is just using graphs how to identify the trend. Now this around 1990, after 1990, the actual production of Legos went very high. So if you see here, if you draw a line, so it's like everything goes very huge. So up to 1990, it is just 200 kind of sets. But after that, they have gone very huge number of sets. Now we will be looking after the next thing. So now if I want to summarize, so this is what we have identified from last thing. So we will be using the next is like the dot aggregate dot agg function. Agg method you can call it as. So generally how to summarize data. So it is like a group by function. Generally we group by data according to some column, but if you want to another column where we want to apply some kind of functions, like for example group by year we are doing, but in the theme ID we want only unique themes, then we can actually use this kind of aggregation method. So that's what we will be using. Number of different themes by calendar year. This means we need to group by data by year and then count the number of unique theme IDs for that year. So what we are doing, so we are grouping by, and then we are aggregating. If you see the theme ID, so for that year, if we have multiple theme IDs, so it will get us the count. How many different, for example, there are 10 records, but the theme ID is only 3. Then we will getting only 3 count as 3. So that's what we will be doing. So dot aggregate. Uh, so I will be showing it here. So themes by year, I'm just rerunning again. So here it is like a dictionary. So here we have explained why method take dictionary as an argument. In the dictionary we specify which operation will apply. It's not only like we are applying any unique, we can apply uh, what are the pandas supported. For example, if you want to apply mean, median or mode for statistical analysis. Now this is one of the easy way, and for data science it is very important to apply aggregation methods and how to check the data. So now I'm just renaming the column theme to number of themes, and then just we are checking head. So in 49 there are only two themes, 1950 one theme. But if I just check the latest, the last 5 records, I think in 2020 we have one or three themes, but in 20 as of now 81. In 23 there is only one or two. In 2021, 22 there are 98 and 90. Now again the same thing. We'll be plotting as of now. Before we have plotted sets per year. Now we will be plotting themes per year. So it's like again this is if we consider old data what we provided in the last PPT zip file, then it will be including this. But if you have downloaded the latest file, we need to exclude only 2024. So I am excluding only 2024 record. So so now the next, if we want to plot side by side the same graph, so how many themes or how many sets per year we just want to plot, we just will be calling the two plots, right? What we have called for Java and Python, if you remember the before data where we are learning about the data visualizations. Then we just call two plots and then we are given different numbers. So similarly, what we are doing here, we are plotting the themes by year, index the same. We are using from starting to end minus 1. Here themes also from starting to end minus, so like, so number of themes and set. If we plot something like this, here if you see we have only one axis. So and this is like, for example, this is themes. Themes is having very high number of, but sets are very low number, so it is not correctly populated. So the graph, it is not very uh, informative to analysis. So what we can do is we can actually have two axes. If you are plotting, if the same x-axis is same, so the year will be same, but we will be plotting two kind of axes. So that it will accordingly adjust automatically the axis, y-axis 1, axis 1, axis 2. So yeah, something like this we will be. So if we just checking this axis 1 equal to, we are getting that axis using plot variable like whatever we imported dot get the current axis, and then we are creating another axis, axis 1 dot twin x is like creating another axis, but it shares the same x-axis, and then we are just plotting according to the axis. So axis 1, axis 2, if I just run it. So if you see here, it is actually having only 100. Here it is different, 1200 axis, but it is not feasible to distinguish, right? Which is uh, themes and which is sets. So and what scale is this, and this is we can identify by year, but it is good we have labeling. So the same thing. So if you see here the plot, here we are can give color equal to G for themes, and you can give blue, it's directly you can directly can give like this, or just if you pass something like this also, it will be consider it as a color. So now we are setting x-axis label, y-axis set axis 1 label, axis set y-axis 1, y-axis label, so it's the number of sets in green. So because why we are setting to green, we are set our plot also to green. So similarly, so if I just run this, so if you see number of sets, here it is number of sets, it is here number of themes. So here if we just axis is same, so number of sets is like if you see here 80, but for that 2020 10 or 2020, for example 2020, there are 100 sets, but here it is like about near to 1000, above 1000 sets are there 2020. If you see about 1000 themes to say. So now we will be going to the next thing. So this is like how to with separate axis opposing line charts. So now we will be looking after scatter plots. So again we will be seeing like more complex, larger, more complex over time. So let's look at average number of parts per lens. So average is nothing but, if you know, it's like a mean. So average of all the number of parts in that year, how many number of parts is produced in that year. It's like we will be taking number of parts all for all the sets, and then we are just for example, it's a there are 10 sets for each year, and number of parts, for example, every set is having 20 20 20. So if we take the average like 20 into 10, like 20 times 10 divided by 10, so it will be 20. So average is 20. But it's not straightforward, right? It might differ according to set. It will be differs. So now what we will be doing, we will be using the same parts per set and year as index. So we will be taking year as the index and contains average number of parts. So if you consider here, the same thing will happen. So group by will be here and aggregate. So here we are passing a dictionary onto number of parts column name. So and then we are giving and pd.series.mean. So here what it will do, it will actually average it, and we will be getting all the average parts data. So for each year, how many averagely how many parts are created. So for example, if you just this one, it is like if you see the same in 1950, there is only one part, it seems, averagely. So there are 99 parts, 1949. So it depends. So yeah, if we check for a latest, at least, so because we don't consider 2024, but 2022 it is like at least there are 287 parts. So it's like in averagely for each year they are producing at least 283, 287 parts they are producing. So now if you want to just plot it, this data, so how will you plotting it? This, so dot representation. So we have given this. So it's like it's again the simple, but it's the same thing. It's we will be calling scatter instead of plot. So plot plt plot this variable plt dot we are calling instead of plot we are calling scatter, and the same thing. So parts per set, and we are not taking 20 24, the last record, the same number of parts we are not taking, and then we are plotting it. So if you see in 2020, it's around here this kind of. So it is like upward trend. So again, if you just go back, yeah, it is like only upward trend it is going. So every year they are increasing number of parts, average number of parts what they are producing. So this is just how from the chart we can identify the upward trend and the size component based on average number of parts. So yeah, so then you increase. So our graph is more like more upward trend. So if you see, so here so it's like upward trend in 2000, from 2000 upward trend, and then it decreased, and now it got again increased. So now it is one of the again main things. So for example, now so for each theme ID, how many uh, counts are there? Like how many sets are there? So we will be just checking all this. So first of all, we will be checking what let's create this. So now we just go back to here. So like this, set the setting count equal to sets. The value counts. So if I just I am correct sets, I have to call set is a keyword, so we should not be using. So I think already the sets is the data frame. Just sets. So if I just so font dot add. So the theme ID 158 is having 931 times it got repeated. So yeah. So but we don't know what exactly here. So which set is having that kind of name, because we can't have any theme names here. So it is like for now just so our themes, so we can see that one is the largest containing, so even now it is the largest containing, having around 931 sets, but we need to find a theme ID, right? So it's like, so how we will be doing it is from this. So as of now this is again text. So here I think this is available here also, so just but here for example in the set there is a theme ID, in the themes there is a ID. So these two are keys, so primary keys for this IDs. So and we have like colors, another data frame. So we are taking three data frames, for example this colors, sets and themes. So in this we are having this two theme ID and ID. So we will be, what we will be doing, we will be merging on this, so that we will get depending on theme ID we will get the name, and then we will be checking which exactly having highest number of themes. So just we have schema like many relation, so individual tables. So it's like if you split in individual tables, colors, themes and set with a relational database, tables are linked to each other through their keys. So again the same thing, if see here theme ID, ID, so all these are related, like so ID in colors, ID is the primary key, in themes ID is the primary key, and even theme ID in sets theme ID is the primary key. The themes.csv, that means theme ID is a foreign key inside sets.csv. Many different sets can be part of the same thing, but inside themes.csv each theme ID which is just unique, the uniqueness makes the column primary key. So here okay, in sets theme ID is not a primary key, but rather than it's a foreign key. For example, many different sets can be part of the same theme. So set ID is the main primary key. So if I just go back, set number for example, set number. So many different sets can be part of that theme, but inside themes there is a theme ID. So this two will be related. Just ID is unique, so uniqueness makes ID. So theme ID should not be repeated, like primary key should be unique mainly. So this is how to understand. So it is like if it's a table, we are having three tables. Again, I just go back here, theme ID, and ID like colors. So we are more concerned about this theme ID and ID. So depending on this theme ID, we already see in counts because it's got repeated every theme ID. But set number, it will be unique mainly. So theme ID can have multiple set numbers. So here the primary key, but it is actually a foreign key. When we are merging these two sets, it will be on this foreign key. We will be merging with this unique key, so that we will get all the names. So for the set X, we have one theme ID, for example 158, and the set X is in theme ID 1. It can be in theme ID 2, like I'm going to say the same 158 set. Yeah. So the so mainly the sets numbers. Yeah. For example, the set number is some XYZ. So it can be in theme ID 1. So 158 uh, can have theme ID multiple times, like 158 XYZ having 158, 158, 158, 158. So but we need to get the same name also. So here, so we will be matching this. So it's like an joining we will be doing. So but in data frame, join is nothing but match. So we just yes again. So as of now we haven't had the instances. So let me read that. Inside data. Let's see. So yeah, so we are having ID name according to that, and we'll checking parent. Parent ID is nothing but what are is available. Now, so search for the Star Wars. How many ID corresponding to that Star Wars are there? So it's like again we are just filtering. We'll be filtering out on this. So so we already seen how to filter. Start. So we are using dot notation. You can use square rotation also. Star Wars. Yeah. 1, 2, 3, 4. So we are having multiple 4 with theme ID 4 with name. So yeah. So now if I just see, there is only 4 records where the name is Star Wars. So now if I just, why would Star Wars have so many different themes? You can check. So now let us just set number. We will be slicing sets on the theme ID. For example, now sets dot theme underscore ID, of course already seen, equal to 18. Yeah. Now there are multiple parts. There is no part in this actually. Okay. So the set number is having a different number. So yeah. So for this theme ID, we are having different sets. So for example, for same theme ID, we are having different sets. For you see here. Now, if I just want to check what is 209 about, so we just so here we are having C 18 158 209 261. We just take off 09 when theme ID is 209. What it is? So even 2024 they have produced. If you see here, it is not 0 and 2023 also they have produced. So it's like Star Wars Abundant Calendar. So it's like calendar. I think they have produced. But what about 261? Just I'm checking everything. So it's like only two are there, and it is present 1990 and 2000 dark side developer. If I just check what is 158 about, because it is having many things, right? So it's like, yeah, it's 931 rows and 6 columns. So yeah, theme ID, if you see set number 2076, there are multiple names for, yeah. Now let's go to next. So here let's give this name. So there is no so set theme count, we already set it in the theme count. For example, set theme count, I think we already run here. So here there is no column names. I meant to say theme ID, only theme ID, and we have got value counts. So this head is, this is again if you remember, this is a slicing thing only, like top 5, it is just like head, whatever we call it as head. So now we will be converting the same thing into a count, like a data frame. So this is index and this is count. So dot data frame, and it will be keys. So now I will be giving ID. It's like ID control Z. ID is the theme column name, and what is that? We are using the same uh, variable. If you just dot index comma count the count set count values. That's so I am taking index, so the value counts and the values. So for that theme IDs, so we are what we are doing, we are just converting that I want to say, you can say as series. So now I just converted. Let's syntax, right? Okay, frame, sorry. I should dot data frame. Okay, sorry. Should capitalize. Yeah. If I just want to check dot head, what happened again? Okay, I think already I have set it. That's why I just uh, when I'm trying to create again, it won't create. So again, I have to run this first, and then if I want to run create a data frame again, now it got, because we have used the same variable, that's why it is giving us issue. So that's what it's better we don't be using same variable twice. So just for the reference purpose also, this is the same thing. Yeah. Now, so now what we'll be doing, we will be matching set theme count and the themes ID on. So for example, so, so this is, so now why we have changed our column name to ID, because in themes there is only ID is there, like a key column. So what we did a theme ID to ID, and here the theme in themes the ID will be similar. Now we will be matching. So match data frame is like pd.match the first data frame set theme count. Now whatever we created this one, and themes is already we have while created that data frame, right? Themes using themes.csv, and on, so it is the key column where we have to match the data. So is working fine. We have on, sorry, head, dot head. Yeah. So if you see here, we have matched with set count. So it's like for ID theme ID 158, it's like 931, but it is like Star Wars is having highest number of set count. So now, if creating bar plots, so again, so let's create uh, 10 10. What are the top 10 having how many things? So it's like here again we are slicing that. So again, it is like plot bar. So here we are calling bar plot. Here we are doing name. Column 10. So uh, 10. So how set count against. This is axis, y-axis. So just plot it. So it's like everything is it got plotted, but it's like it's not readable, right? So for that we actually need to configure how our graph looks like. So like again we have to give a figure size, how much it is there and how much it is. How much it is. Yeah. So uh, okay. So here because we can't able to read anything, so we will be configuring our plot. So now the figure size is like 14 by 8, so it is like pixels. Now what if the x-axis is like 14 and rotation is like 45 some. So because we just want our graphs or our x-axis labels should be visible. So similarly y-axis we are not giving any rotation. So y label number of sets and x label a theme name. Now the same thing here, if you observe, I have used square notation. Now it is here we are using dot calling using column name using dot notation. So now if you see here, yeah. So because x-axis is the same now, I think hope you got clarity why what is the x-axis. So we have given a 45 degrees rotation. So that's why the parts or the names whatever on the bar plot, it is actually rotated 45 degrees. So if I just change to 60 degrees and let's try to do it. Just for checking this. So it is not, I want to say, not very aligned. If I just change to 90 degrees, see how it behaves. Yeah. So now it is clearly visible. So how the rotation changes. So how for this we have given the font size. Yeah, I think for easy reading, I think 45 degrees is the best. So it's like books, keychain. Star Wars is having the highest number of sets uh, till today. So again, the same thing. So this is everything is created with using old data what we provided in the last PPT GIF file. So if we do the same thing using that GIF file, you will get data using that GIF file. You will get this type of graphs. So just the say yeah. So because we have like more 4 years of data, it got uh, the the x-axis got changed, but it is Star Wars. It's like gear, but now if I just check, keychain is the more having more number of sets, and then gear, friends. So, but if you take old data, I think friends keychain is at fourth place. Now it came to second place. Yeah, and then yeah, the final just for revising. So how to uh, like insert HTML markdowns in notebooks, and how to bold or how the headings using hash notations in the notebook we have seen, and group by and count functions and value counts function we have seen, and aggregate function and the square bracket slicing. So it is like from starting to end end minus 2. So it's like it will exclude last two. So this is just like list slicing, the same thing. It's so from starting to 10. So if you want only up to 10. Now an aggregation function. So to rename, how to rename columns. So line chart using different like two accesses uh, we have done. Now scatter plot also we have seen. Tables like what is primary key and what is exactly the foreign key. So we have seen that like using themes and sets data. So if I just again, if I just go back, yeah. So here, yeah, for this is in themes ID is unique. Themes table or in themes data frame, but in sets data frame theme ID is not unique. But uh, we can merge on this because actually this is a foreign key in this set, so that we can directly match on this. So we actually did what we did. We actually converted theme ID and its counts into a data frame, and then we matched it. Yeah. So now we have how to use match. So yeah, and we have created a bar chart. So again, here what it will do is whenever by default whenever we don't mention how, it will by default it will do the inner join. So whatever themes available in ID and both of the data frames, then only it will match, otherwise it will leave. So otherwise it won't. So it takes only intersection of the all the IDs whatever available on both the frames. So if you see here, just it is loading. Yeah. So how merge equal to how is inner is by default it will be. So but we have multiple options, like all another three options are like left merge, left, right, and outer. And we can add different labels, suffixes. So when you are matching, if you want to give column names, some suffix like you are using to production data and staging data or UAT data, SIT data. Then if you want to match both, you need to distinguish from columns which column is which thing. Then you can use that. Yeah. Mm, yeah. So we have seen how to plot bar charts using and what is ticks, what is whiting, how to configure ticks and everything. Yeah, that's it. For today, I think aggregation and merging data is done. So you can do your research more on this. And this is one of the important topic like aggregation, merging, and grouping by, and how to plot different charts like scatter plot, line charts using different axes and bar charts. Yeah, that's it for today. Thank you.